So in this problem, we're given a sequence A of length n, and it has numbers between 1 to n. But the sequence may contain duplicates. So that means that the sequence of length n isn't just 1, 2, 3, 4, 5, 6, 7, 8 till n. Yes, that can be the sequence, but the sequence, let's say when n is 3, could be 1, 3, 3 or 1, 1, 1, right? It's just any numbers between 1 and n, and the size of this sequence is n. So for this easy version, they fix m as 3 and k as 2. So m is the size of the tuple and k is the difference, right? So in this problem, what we're doing is we are taking a tuple of size m, and then we find the maximum and we find the min of this tuple, and then if the max of this tuple minus the min of this tuple is less than equivalent to k, then we increase the count by 1, and we just want to find the number of such tuples such that the max minus min is less than equivalent to k. And in this case, the size of the tuple is fixed to 3 and k is fixed to 2. So we want to find the number of tuples of size 3 such that the max minus the min of this tuple is less than equivalent to 2. Right? So let's go, as an example, let's do 1, 2, 3, right? No, not here, let's do it here. 1, 2, 3. So if you take this other tuple, the max is 3, min is 1, the difference is 2, and it's less than or equivalent to 2. So this would be valid, right? But let's say our sequence A, or let's call this A, is 1, 2, 3, 4. Now the sequence, if we chose the numbers 1, 2, and 4, the max is 4, min is 1, the difference is now 3, so therefore this condition would not be held, and so we wouldn't add that to our count. So this seems very tricky, and it kind of is, but once you see how to solve it, then it's just pretty straightforward. So let's say we have something like 3, 1, 2, 2, 3, 5, right? And let's create a frequency array. So let's call this P, right? So initially, so index 0, I think it mapped so it's easier to see. So 0, 1, 2, 3, 4. So index 0 would correspond to 1 because 1 is the smallest possible element you can have. So the number of 1s we have is 1, the number of 2s we have is 2, number of 3s we have is 2, number of 4s we have is, actually that's just confusing. I'll just do it this way and then I can change it when I code. So number of 1s I have is 1, number 2s I have is 2, number 3, so number 4s I have is 0, number 5s I have is 1. So now looking at this, let's look at 1, 2. So if our lowest number is 1, then our maximum possible value is 3. So if we have numbers from any of these 3 sets, then they will work with this condition because it's less than or equal to 2. So let's say let's say if we just focus on the numbers 1, 2, and 3, a possible set of size 3 could be 2, 2, 3, or 1, 3, 3, or 2, 2, 1, or so as long as we pick any of these numbers to form the set of size 3, we're fine. So the total number of 1, 2, and 3s we have would be 1 plus 2 plus 2, which is 5, and we have to choose 3 of these numbers. So it'd be 5, choose 3. Same thing here. If we look at 2, 3, and 4, so in this case max would be 4, min would be 2, and the total number of elements that are either 2, 3, or 4 is 4, and so there'd be 4, choose 3. So there'd be 4 ways to make this possible. Yeah, so we just keep on doing that. But the key thing is, if we do it using this way, then we have to take into account that we count some tuples more than once, right? So in this 1, 2, 3, right? So if we pick some numbers that are either 1, 2, or 3, then one possible tuple would be 3, 3, 2. And then if you look at the same thing for 2, 3, and 4, again we can see that 2, 2, 3 or 3, 3, 2, that's also valid. So we count it. So we count the tuple 2, 2, 3 once here, and we count it also once here. So we count that twice. So to take that away, we just have to look at the number of numbers such that the value is either 2 or 3, and then we take that off. So here it would be 4, choose 3, right? Because we count that twice. Yeah, I think let me code this first, so then it becomes a bit easier to explain. So is there a t? There probably is a t. In t, in t, while t minus minus, we solve. Okay, and then we're given n. We read in this n, then vector, then a and 0. For n, so let's read in some temp x, and then since a is our frequency array, we would just increment a of x. But let's zero index everything to make it a bit nicer for me. Okay, I'm going to count all such pairings. So for I between 0 and n minus 1, yep. The sum, so we basically sum up ai plus 1 plus ai plus 2, and then ans plus equivalent to n choose 3 of sum and 3. Okay, so just n choose 3, and where n is the sum, right? And then so what this does is we say, hey, okay, we're here. Now let's look at the next 3 numbers, and let's count the sum in their frequency array A. So in total, we have 5. And so now, using these 5 numbers, we just have to pick, we have to find the number of ways we can choose 3 numbers. So which is 5, choose 3. So let's just code nc3, and then so we're given the number n, right? And we just want to return n times n minus 1 times n minus 2 over 6. Yeah, this is pretty well known. Okay, so that all works. Then for I between 1 and n minus 2, the new, so we just look at ai plus 1, and then ans minus nc3 of sum, and then we just see the answer, and a new line as well. Okay, so what is the point of this? So just to go over it again, let's look at using the numbers between 1 to 3 first, right? One possible pairing, if we do this 5 choose 3, right? So we just pick 3 numbers from either 1, 2, and 3. Like, yeah, we could have, here would be 2, 2, 3. Now, if you look at the numbers 2, 3, 4, and again here we do 4 choose 3, one possible pairing that this 4 choose 3 counts is again this 2, 2, 3. And therefore we count this pair twice, and we don't want that. So what we do is we count all these pairs. We count this pair, oops, sorry, the 1, 2, 3, 2, 3, 4, 3, 4, 5. Yes, right. But then we also have to count this 2, 3 again, and then we find all the possible pairs formed just by this 2, 3, because that's counted both in 1, 2, 3 and 2, 3, 4, and we take that away from our answer. So here we look at 2 plus 3, the number of 2s and 3s we have is 4, then 4 choose 3 is 4, so we take away 4 from our answer because we added 8 here when we were only meant to add 4 because of this counting twice, and therefore we have to subtract that from our answer. Oh. Hopefully this works. What's wrong here? Did I mod anything? Div to int somewhere shouldn't have. Or should it be long? Wait, what is possible numbers of E1? E1 can be anything between 2E5. Oh, but then that should not be an issue. N times n minus 1 times. Ooh, this is the issue. If I do integer multiplication, then this value will be an int. Okay, yeah. So we're to pass in n as a long, so when we do this, when we times everything together, this value will be a long as well. Even though the output is a long, if n is an integer, this n times n minus 1 times n minus 2 will be an integer. Okay. So I believe that should fix it.